Welcome to my channel. In this video, I am going to discuss how to write the laboratory manual for verification of Kirchhoff's voltage law and Kirchhoff's current law. That is verification of KVL and KCL for the given circuit. Now, before discussing how to write the manual, so if any student is watching this video, they must know how to copy down this manual in their observation. For that, I have prepared another slide. In this slide, in general, for all the electrical laboratory experiments, how to write the observation or record that I have mentioned here. So you can see here, one second. So you can see on the right side page, you must write the title, date and experiment number. On all the right side pages, okay, only on the right side pages, you must write aim, apparatus, required, theory, procedure, formulae, calculations, theoretical proof, practical proof, precautions and result. Okay, so this sequence must be followed to write the observation. And only on the left side pages in your observation, you must draw the circuit diagram, observation tables and model graphs. For this experiment, for the verification of Kirchhoff's voltage law and current law, model graph will not be there. So this slide is applicable only for, in general it is applicable for electrical laboratory experiments. So, but for verification of Kirchhoff's voltage law and current law, model graph is not required. So let us start with the title. So title is verification of Kirchhoff's voltage law and current law for the given circuit. Of course, I didn't write for the given circuit. If you want, you can write that. Or you can simply write verification of Kirchhoff's voltage law and Kirchhoff's current law. This is our title. Now, aim of our experiment is, the aim has been divided into two parts. Why? Because I have written this manual for the hardware experiment as well as for software experiment. Here using a circuit board. Okay, if you are doing the experiment on a circuit board, then you can write only the first aim. If you are also doing the experiment using MATLAB software, or then you can write the second aim also. So the aim of the experiment is to verify Kirchhoff's voltage law and Kirchhoff's current law for the given circuit using hardware. And second part is to verify Kirchhoff's voltage law and Kirchhoff's current law for the given circuit using MATLAB software. You can pause the video and copy down this manual in your observation or record if you are copying it from my video. Now, apparatus required. Apparatus required for doing the hardware experiment. So the apparatus required must always be written in your observation or record in tabular column. So serial number, name of the equipment, range, type and quantity. So the equipments that are required are regulated power supply of range 0 to 30 volts 1 ampere, and we need two regulated power supplies here. So quantity is 2. Circuit board we require only 1, quantity is 1. Ammeter of range 0 to 50 milliamperes, moving coil type, MC means moving coil type. We need 6 ammeters, so quantity is 6. Voltmeter of range 0 to 30 volts type, moving coil type, and moving coil we usually denote this moving coil into by notation MC. Okay, so MC type voltmeter means moving coil type voltmeter. We need at least 7 voltmeters. So connecting wires as per the requirement. So that's why in quantity I have required number. Okay, it depends on the circuit that you are going to use, and depending on the number of elements in your circuit, the connecting wires may vary. So that's why the quantity is required number. You can pause the video and you can copy down this tabular column in your observation or record. Now For doing the software experiment, the apparatus required is only MATLAB software. So the software required is MATLAB. The software required is MATLAB here. Now let us see the circuit diagram to do this experiment. For hardware experiment, for applying Kirchhoff's current law in the given circuit. This is our circuit diagram. So you can see a DC voltage source, that is our regulated power supply 1, whose range is 0 to 30 volts 1 ampere. Okay, this is our regulated power supply 1. Another regulated power supply is there. This is it. So regulated power supply 2, RPS 2, RPS 1. The range of the the range of the RPS that we require is, the voltage range is 0 to 30 volts 1 ampere. Similarly, RPS 2 range is 0 to 30 volts 1 ampere. So notation of this RPS voltage notation is V1. Voltage across this RPS notation, we are giving some V2 notation. So whatever voltage that you are going to set using this RPS 1, that voltage is measured by this voltmeter, whose range is 0 to 30 volts MC type. The current that is coming out to this supply, it can be measured by this ammeter, whose range is 0 to 50 milliamperes MC type. And in series to all the elements, since we want to verify Kirchhoff's current law, in series to all the elements in the given circuit, we will connect an ammeter. So you can see an ammeter in series to 2000 ohms, whose range is 0 to 50 milliamperes, moving coil type. Since the supply is DC supply, that's why you must not forget to mention plus minus across each and every measuring element. So here in series to 1000 ohms, we have connected an ammeter of range 0 to 50 milliamperes, moving coil type. And similarly, in series to this ammeter 0 to 50 milliamperes, moving coil type, in series to this resistor 1000 ohms, we have connected an ammeter of 0 to 50 milliamperes, moving coil type. In series to this 1000 ohms resistor, we have connected an ammeter of 0 to 50 milliamperes, range moving coil type. And in series to this 1000 ohms resistor, an ammeter of range 0 to 50 milliamperes, moving coil type has been connected. Across this RPS2, an voltmeter is connected of range 0 to 30 volts, moving coil type. So this is the given circuit. This is a practical circuit to verify Kirchhoff's current law. So algebraic sum of currents at each node in this given circuit should be equal to 0. You can pause the video and you can copy this circuit in your observation or record. Now for verifying Kirchhoff's voltage law. Okay, for verifying Kirchhoff's voltage law, this is our circuit. So this is our regulated power supply 1, another regulated power supply 2, this is it. So the range of regulated power supply 1 is 0 to 30 volts 1 ampere, and we have given notation V1 to it. And the range of regulated power supply 2 is 0 to 30 volts 1 ampere. Notation that we have given here to it is V2. Now a voltmeter is connected across RPS 1, whose range is 0 to 30 volts and type is moving coil type. Similarly, another voltmeter is connected across this RPS 2, whose range is 0 to 30 volts and type is moving coil type. Across each and every passive element, that is resistive element here, voltmeter is connected. So across 2000 ohms voltmeter of 0 to 30 volts moving coil type has been connected here. Similarly, across this resistor of 1000 ohms, a voltmeter of range 0 to 30 volts moving coil type has been connected across this resistor of 1000 ohms, and voltmeter of 0 to 30 volts moving coil type has been connected across this resistor of 1000 ohms, and voltmeter of 0 to 30 volts moving coil type has been connected across this resistor of 1000 ohms. A voltmeter of 0 to 30 volts moving coil type has been connected. So this is the circuit diagram, practical circuit diagram to verify um, Kirchhoff's voltage law in each loop. There are 3 loops. This is one loop. This is one loop. This is another loop. This is the third loop. So in each loop, we will measure the voltage, and we will verify Kirchhoff's voltage law by simply taking the algebraic sum of voltages in each loop equal to 0 or not. If the algebraic sum of all the voltages in a closed loop equal to 0, then Kirchhoff's voltage law is verified. You can pause the video and you can copy down this circuit in your observation. Now for doing the software experiment to verify Kirchhoff's current law, same circuit we have taken. We have taken the same circuit. So here in your MATLAB, using MATLAB software, that is MATLAB Simulink. Okay, so you will collect this all the blocks. So you require a DC voltage source. This is a DC voltage source. In series to it, we will connect an current measurement. Okay, so this is our current measurement. So this is plus. This is minus. So this block is tilted. This is I. Okay, this block is tilted. It has been rotated in anti-clockwise direction by 90 degrees. That's why I is looking like 1, but this is it. This is current measurement. To the I terminal of current measurement, a display should be connected. So whatever current that is coming out of this source, that will be displayed, which is measured by this current measurement, it will be displayed in this display. Similarly, in series to 2000 ohms, a current measurement has been connected. This is plus. I am unable to write press. I will erase it. Plus, this is I. This is minus. Similarly, in series to this 1000 ohms, an current measurement is connected. So this is plus. This is I, small I, and this is minus. Here also this is plus. This is I, and this is minus. Here again this is plus. This is I, and this is minus. Here again this is plus. This is minus, and this is I. So this 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 current measurement is tilted. It has been rotated in an anti-clockwise direction by 90 degree. That's why it is tilted here. This is current measurement is also rotated by an angle of 90 degree. Okay, that's why this minus is looking like 1 here. This minus is also looking like 1. So these are current measurement which measures the current coming out of this positive terminal, and which will be displayed in this display unit. Similarly, the current flowing through this 2000 ohms is measured by this current measurement. I terminal of this is connected to the display, plus terminal is connected to resistor, minus terminal is connected to the rest of the circuit. Similarly, this current measurement is measuring the current flowing through the 1000 ohms. Whatever current is measured by this current measurement, that is displayed in this display unit. Okay. Similarly, whatever current flowing through this 1000 ohms is measured by this current measurement, and that measured current is displayed in this display. Similarly, the current flowing through this 1000 ohms resistor is measured by this current measurement, and whatever current that is measured by this current measurement, that is displayed in this display. So this is another voltage source. So in series to that voltage source, current measurement is connected. So whatever current that is flowing into this 1000 ohms resistor is measured by this current measurement, and that value is displayed in this display. So whatever current that is coming out of this positive terminal of the source, the same current will flow through this resistor. So you can pause the video, and you can copy down this circuit in your notes. And one more thing that you have to remember is that a power guy, you must select a block from the Simulink library. You must type power guy in that, POWER guy. This is GUI. Okay, power guy. While after designing this whole circuit, and after substituting the values in each and every element, at last you must select the power guy, which is continuous type, from the Simulink library, and copy it in your new model in which you are designing the circuit. Now to verify Kirchhoff's voltage law, this is our circuit for software experiment. So you need DC voltage source, okay, and you need another DC voltage source, and you have to connect across each resistor voltage measurement. So this is our voltage measurement. So across 2000 ohms you must connect the voltage measurement. The V terminal is connected to the display. Whatever voltage that is measured by this voltage measurement across this resistor will be displayed in this display. Similarly, across this resistor of 1000 ohms, voltage measurement should be connected. Whatever voltage that is measured by this voltage measurement, that is displayed in this display. Similarly, whatever voltage that is measured by this resistor, whatever voltage that is measured across this resistor by this voltage measurement, that is displayed in this display, and whatever voltage that is measured by this voltage measurement across this resistor will be displayed in this display. The voltage across this 1000 ohms resistor will be measured by this voltage measurement, and it is displayed in this display. So you need a power guy in order to get the output. So when you run the program, when you debug and run this, in order to get the display values, you definitely need a power guy. So you can select this block from the Simulink library and copy it in your model. Now observation table. So observation table to verify Kirchhoff's voltage law. So theoretically, for the given circuit, you must determine the voltage drops and current flowing through. So here we are going to verify Kirchhoff's voltage law. So you have to determine the voltage drops across each and every element theoretically. So theoretical values: source voltage 1, source voltage 2, voltage across resistor 1, voltage across resistor 2, voltage across resistor 3, voltage across resistor 4, and voltage across resistor 5 must be tabulated in this tabular column. And after doing hardware experiments, you just tabulate all these values in this tabular column. After doing software experiment, you just tabulate all the values in this tabular column. You can pause the video and you can copy down this tabular column in your observation. Similarly, to verify Kirchhoff's current law, okay, so you can you need this table. So theoretical values, hardware experiment values, and software experiment values. The values that you have to tabulate in this tabular column are current coming out of the source 1, current flowing through resistor 1, current flowing through resistor 2, current flowing through resistor 3, and current flowing through source 2, and current coming out of source 2 and current flowing through resistor 4, both will be same. So that's why I have written here or current flowing through resistor 5 and current flowing through resistor 6. So all these must be tabulated in this tabular column. You can pause the video and copy down this table in your observation. Now theory. You must leave at least one page to write the theory in your observation. So I have not written any theory here. You have to refer to some electrical circuits laboratory. I'm sorry, electrical circuits textbook or network analysis or network theory textbook and write down the theory in this in your notes. So procedure. For hardware experiment, connections are made as per the circuit diagram. Apply source voltage of 30 volts to the circuit by switching on the RPS1, RPS2. Note down the ammeter and voltmeter readings in the tabular columns. Calculate the algebraic sum of voltmeters readings values in each loop to verify Kirchhoff's voltage law, and also calculate the algebraic sum of ammeter reading values at each node to verify Kirchhoff's current law. For doing the software experiment, the procedure is to enter the command window of MATLAB, create new model by selecting file, and later select new and then select model. So now pick up the blocks from the Simulink library browser and copy it in the model, and connect the blocks as per the circuit diagram. Set source and parameter values. Debug and run the circuit. Note down the voltage measurement and current measurement values in the tabular columns. You can pause the video and copy down this in your notes. And next, calculate the algebraic sum of voltage measurement values in each loop to verify KVL, and calculate the algebraic sum of current measurement values at each node to Verify Kirchhoff's current law. Now calculations, you must do the theoretical calculations for the given circuit. You must leave at least 2 pages in your observation to do the calculations. Next, you must leave at least half a page for theoretical proof. So verify Kirchhoff's voltage law and current law theoretically for the calculations that you have done. And practical proof. So for whatever experiment that you have done, for that experiment, for both hardware and software, you must verify Kirchhoff's voltage law and current law. So leave at least half a page for practical proof. And precautions, initially keep the RPS or output voltage knob in 0 volt position. Avoid loose connections. Avoid short circuit of RPS output terminals. At last result. So in the result, you must write that you have verified Kirchhoff's voltage law and current law for the given circuit for both hardware experiment and software experiment. So what you can write is for the given circuit, Kirchhoff's voltage law and Kirchhoff's current law has been verified using hardware and MATLAB software. That is the result. Thanks for watching the video. If you have any queries or doubts, you can mention in the comment section. So if anything which is not understood by you, if you want me to explain, you can mention in the comment section. If you have understood, if you like this video, you can click on the like button so that this video can be shared to many other people who are in need of. So this video can reach to many people who are in need of if you click on the like button. Thank you.